these like hemophilia, all such. So let us understand what is H substance, a gene for H substance, and what is Bombay group, all this nonsense. Okay, so this is what written in our notes, but since we cannot read, we can read, but let's go with the concept first. Okay, so just remember that. Okay, now let's understand. Let's start the video. It's very simple way of remembering the H antigen and Bombay group, and no need of taking much tension here. So I have a easy method of teaching you guys. So think that it's you, right? If I take one RBC out, right? If I say one RBC out, our RBC has, right? Our RBC has oligosaccharides on its surface. This is the structure of beautiful oligosaccharides, right? It's just an, right? It's just a oligosaccharide which is present on our body. We have not yet named this blood cell as H antigen or A antigen or B antigen. This is the first step where on RBC you have, right, on RBC you have oligosaccharides. And now how this a simple oligosaccharide can become a H type of antigen. It means H type, H substance. What do you mean by H substance? This is a simple way, this is the first step, right? You understood? On RBC we have got oligosaccharide. Now what happens in H substance here is, you got a chromosome 19, right? You have a chromosome 19 that has a gene, right? That has a gene that codes like gene is like you have got capital H small h or capital H capital H. Any of capital H dominates, that is enough, right? When this is expressed, right, I repeat once again, on chromosome 19 we have this capital H small h, a gene capital H small h, a gene capital H capital H. This codes for an enzyme fucosyl transferase, right? It codes for an enzyme fucosyl transferase. What does it do, fucosyl transferase? Now the pool in our body, it has lots of all the nonsense in our body. You have got fucose, you have D-galactose, N-galactose, all those mutton, chicken, beef, everything is present in it, right? Now this fucosyl transferase, right, this is an enzyme. It doesn't take mutton, it doesn't take chicken, not in French rice. It takes only fucose and it binds here. When the fucosyl transferase takes fucose and binds to the galactose, and now this RBC is known as a H substance RBC. This is H antigen is present now. That means H substance. Just remember, meanwhile it is H substance is present, right? And now how this H substance, how this RBC can become A type or A antigen, how this H antigen or this RBC can become B antigen, right? Now in the next step, right now on RBC what do we have? We have oligosaccharide and we have got fucose, and as we told before, and now this whole thing is known as H substance. This is known as H substance or H antigen, right? And now this H antigen, right, should convert to either A antigen or B antigen depending on the blood group that baby has, right? Depending on the blood group he has. Suppose if he has a blood group of A antigen, right, if he has a blood group of A, then what does it do, right? When he has a blood group of A, the genes which code for the blood group A, they produce an enzyme known as A transferase. These transferase get this N-acetyl galactose from this pool and they attach here. Once they attach N-acetyl galactose, once they attach to this galactose, right? Now what happens? The whole of this becomes A blood group, right? The whole of this become A blood group. Instead of, right, if a person has a B blood group, right, how does he have blood group? Now you have got a gene on the chromosomes which code for the B blood group. They produce an enzyme known as transferase. That enzyme, instead of N-acetyl galactose, it brings D-galactose and bind to this oligosaccharide, and now this RBC becomes B blood group, right? Now this is known as B antigen, this is known as A antigen. The difference here is this is N-acetyl galactose and this is D-galactose, right? Now suppose, right, in some condition, okay fine, we finished with this A blood group, we finished with the person who have B blood group. Now what about the person who have O blood group? A person who have O blood group, right, it's single, it's not ready to mingle, right? It's single, it's not binding with either the N-acetyl galactose or D-galactose, so it is still single. And now if it has only H substance, and this is known as O antigen, right? This is known as O antigen. This conversion of O antigen to H antigen all people. So what happens to 0.1%? In such persons, there is no double H and small h gene, so there is no fucosal transferase. If there is no fucosal transferase, there is no binding of fucosal to galactose, so it has only the oligosaccharides. And now this type of antigen or blood group, we call it as Bombay blood group. Call this as Bombay blood group. So that is the basic concept what you should understand from here. And now let's read our notes for better understanding. Right? I told gene for the H substance is present on chromosome 19. Yes. On RBCs, there are precursor substances, oligosaccharide, I thought you, right? And these double H and these genes are responsible for the production of fucosal transferase, right? That brings the fucosyl to the oligosaccharide, right? This is known as H substance. And now for the H substance, if N-acetyl galactose come, it becomes A antigen. If D-glucose will, then it converts into B antigens, B blood group. If nothing is attached, then it is H antigen remain unchanged. Now it's known as, it has only O gene. That means nothing is there. Now in some conditions there is small h, right? If in such conditions there is no fucosal transferase. If there is no fucosal transferase, what happens here is the precursor substance remain unchanged. That means it's just an oligosaccharide. Right? Hope you are understanding now. It's very simple. Right? So I repeat once again. So H substance, you have a person who has A gene product, they synthesize a transferase enzyme, right? That is N-acetyl galactosamine transferase enzyme that brings N-acetyl galactose and binds, and we get A blood group or A antigen. Person we have B gene product. Now there is transfer of this transferase bring D galactose. This transferase bring D galactose and bind here, and this is known as B blood group or B antigen. If there is no change, this is O antigen, right? H substance has no change. Now let's see here, precursor substance oligosaccharide, right? In 99.9 there is, it express this formation of H substance. So there is a formation of A antigen, B antigen, O antigen, then precursor, right? Precursor substance remain, and this is known as Bombay blood group. Nothing has happened here, right? So let's see what are the antibodies which are present in such persons. If a person has A antigen, right? If a person has A blood group, that means the antigen present here is A antigen, right? And that part fucosal, and that is also H antigen, small part. And what is the antibody present? The antibody present is, of course, it is anti-B, right? If you have a blood group B, you have an antigen B and H. Antibody present here is, yes, of course, anti-A. If you have both the antigens A and B, so you have A, B and small part of H. And what are the no antibodies? Good. If a blood group is O, there is no antigen, no antigen A, no antigen B. That is H antigen, right? Only H antigen is present. So we have anti-A, anti-B. I spoke, right? The 0.1% they have a Bombay blood group. In our, it's just random to understand. There is nothing. There is neither A, neither B, neither H. So you have an antibodies of anti-A, anti-B and anti-H. Hope you understood the concept. Let's finish this by reading few important points regarding this. This A, B and H, the whole process appears on RBCs in fetal life, but they are fully developed by 1 year of age. When does it appears? It appears in fetal life, and fully developed by 1 year of age. Now we have got antibodies to A, B and H antigens are produced by 3 to 6 months of age, right? 3 to 6 months of age. That time these antibodies are produced, but the antigens start producing from fetal life, developed till 1 year of age. But these antibodies, they are produced by 3 to 6 months of age. Remember that, 3 to 6 months. But here it's fetal till 1 year. These antibodies are naturally occurring IgM class of antibodies, right? IgM. Most are IgM except in some group of O individuals, some group of individuals, not O, some group of individuals, both IgM and IgG classes of antibodies are present. So that is all regarding the H antigen and the Bombay blood group. Hope you understood. If you understand, it's good. Fine. Thank you. Bye. Let's see next video.